Hello and welcome to the day 3 of system design sessions where we are analyzing one semantic layer generation using AI asset. So that is our use case. This is required to understand whatever the architectural principles we are discussing. Those are required to build any kind of AI agent system or the agentic AI systems. So whatever we are discussing the concepts, we have to apply that into our use case, that is the semantic layer generation. So it does not mean that only this kind of architectural principles are applicable to only this use case. We are trying to understand whatever the, in a very holistic manner, whatever the complete set of architectural principles, concepts are required to build any kind of agentic AI system, not only defined into this specific use case. So that once you are very much clear about the concepts with some live examples about on this particular use case, then we can apply all those principles and concepts into building any kind of agentic AI system. So that is the intention, and just try to understand why I'm again and again I'm saying like that. Okay, semantic layer generation AI agent. This is just one use case we have considered to learn our complete session, system design session. It is not some kind of strictly applicable to only this domain. So now it's clear what we are going to learn and what are the different examples or use cases we are considering for this. Now coming back to the day 3 topic. Day 3 topic is to know domain, is to apply domain driven design to our agentic AI system. So what is domain driven design? It's an architectural framework to design for the system design of any software applications, and that it centers development on the core business domain by using some kind of ubiquitous language. Ubiquitous language means those language should be understood by all the entities, by all the concepts defined in a business, in a boundary context. So what is that boundary business context or the boundary context boundary? That means we have defined that some set of operations can be performed inside this particular boundary by this set of entities. Okay, second term is that, okay, so here we learned the first term, bounded context, boundary. What is the bounded context? Boundary context. Okay, second is that entities, and anyone can understand that. Okay, these are set of columns, these are set of entities which are describing our domain. You can take any domain. Okay, for example, healthcare domain if you consider, then there will be some entities like patient, doctor, diagnosis, medicines, administrator. So again, those entities like patient ID, patient DOB, patient name, what is the diseases, then doctor's prescriptions, all those. So these levels, what it's uniquely identifies a specific entity like customer ID. Okay, so with the customer ID or the patient ID, you are having one kind of identity. So here what you can say that everyone knows this is, I am not going depth into this one entity, so it has some kind of identity. The third concept is that value object. Value object does not have any kind of identity. For example, if I say like that confidence score, okay, we are using LLM and we are evaluating something and we are getting some kind of confidence score. So there is in our complete data model, there is a column named as confidence score, but there is no column named as confidence score ID. Similarity score, embedding score. Okay, so these are called as value object. And the next one is about aggregated node. So this is a cluster of the entities which can be aggregated to define one kind of concept. Okay, closely related. And the next one is audit trail. So whatever the operations we are happening in a bounded context, There will be defined that what kind of operations can be performed, who can read it, who can write it, who can alter the entities attributes available inside that one. So these are some concepts that you are well aware about the system design, domain driven design, all these concepts. So I'm just telling you all those concepts we have to apply in our system design of agentic AI system. Why this is required? Because see, LLMs are probabilistic, okay? Until and unless we don't restrict them with a strict business rules inside a bounded context, they will give result in a probabilistic manner. If we had not provided all those informations, they will start taking decisions because they are having reasoning capability, they are having decisions taking capability, and those, when it reflects to our systems, that will be entirely different than our expectations. So system design is very much important. What should go inside the LLM, what should go inside the agent, there is a strict boundary context with all these attributes are required in order to understand. So let's start to understand all these concepts, how this we can apply into our use case, that is the semantic layer generation. What are the different bounded contexts we have defined, what are the aggregates, what are the value objects can be possibles, and then from there, once we are clear with that one, then it will be very easy for tomorrow's session where we are building the state schema. State schema is very much required in a LangGraph based project. Any agentic AI system project is defined what are the set of inputs it is going to one agent, what is the output, and who has the authority to update any informations defined for that specific agent. So let's start. Understand bounded context. Okay, so here I have to take now you are very much clear about what is the different processes, so the complete process diagram of our use case, that is semantic layer generations. So what it does is that it is having, in last yesterday's session what we learned is that it is having some set of deterministic states and some set of ambiguous states, and we had applied 4 principles how to come up with which steps should go implemented as an autonomous process through some AI agent. So with this complete thing I can say like that, okay, there are 2 bounded contexts we can say. The major operations what we are going to do, one is that ontology and the semantic context, and the second one is about governance and access context. So here if I write down this ontology and the semantic context, here and this one is about governance and the access context. What are the major features of this layer? It is like we are generating the ontology and wants to give some semantic layer informations, semantic context, and again we are restricting who are the users should be able to access what kind of informations. So that is the governance and access layer. So these are basically things. One is the building and another is the accessing the governance. So in this case what I can say is that boundary context is a boundary within which a specific model and the specific language are consistent and unambiguous. Outside that boundary the same word can mean something different, and that's fine. That is expected as long as you have drawn the line explicitly. Okay, So we should not expect like that, okay, this specific entity is defined, that means it cannot be repeated, but that is repeated in another bounded context. So here what is this? The ontology and the semantic context, this is where we can answer what does the revenue means, okay, and how does it relate to bookings. And inside this governance, we can answer who is allowed to see this column and what compliance regime applies to it. So its language is like policies, roles, sensitivity classifications and audit events. While this ontology, its language is like what is the different entities, what is the relationship, what is the object properties, what are the data properties, what is the glossary terms, and this language, when I say language, this initially I had told that ubiquitous language, strict ubiquitous language, right? So this here is why the boundary matters correctly. Inside the ontology context, customer might be very rich business entity with dozens of attributes and relationships. Inside the governance context, all that matters about the customer is about whether it is linked with any PII and which roles can access it. If you build one shared customer model trying to serve both contexts, you get a blotted object. And that's hard to reason about, and worse, a system where a change made for ontology reasons can accidentally break an access policy or the vice versa. So now you got why we are dividing into bounded context. So next is about, if I say here some kind of anti-corruption layer design, ontology context, then translation layer, then purview or the Colibra API. So these are some kind of what it happens now. This is where, and that's direct. So this is where somewhere we had analyzed the build versus buy analysis, and that was like connects directly to the DDT and like these two concepts. So here what happens now, when the governance and the access context substantially overlaps with some tools, available tools, for example we can consider about Colibra or the Microsoft Purview. So in that case what happens, this tells you what context should mostly be an anti-corruption layer that translates into, and out of those existing systems, not a context you rebuild from the scratch which can be used, and what should be behind the anti-corruption layer. So next term is that, this is we learnt about bounded context. Name is that aggregate root or the aggregate node. So aggregation, I had told, cluster of domain objects that must be treated as a single consistency unit. So you never let part of an aggregate into an inconsistent state relative to the rest. So in our natural language aggregates, there is a term as semantic artifact. So what are the different domain objects inside this aggregate root? So it is like, it's a clusters of, what I can say, it's a cluster of business glossaries, business rules, then some kind of entities, relationships, some kind of mapping, right? All this will come inside there. So all tied to one physical column or the some in concept. So why does this matter practically? Because it tells you the transaction boundary. When the semantic validation agent approves a mapping, the confidence code, the approval status and the audit entry all have to update together atomically. You cannot have a state where the mapping shows it's like something, it is not related to any kind of informations. So what happens here, you cannot have a state where the mapping shows approved but the audit log does not yet reflect who approved it. That's it, like the system is broken in that case, right? So this also directly answers the questions like the semantic artifact aggregate is a shared state, and every agent reads and writes through this aggregates boundary, not through some kind of shared variables. So next part is coming. What is that here? Is the value object. So I had already told that it does not have any kind of identity. You can say like this kind of scores, it will be defined like this, okay? So every semantic decision must be auditable and every semantic artifact is versatile. So confidence score with its explanation score is like 0.8, to explanation is matched via ontology hierarchy distance plus 3 historical agreements. So this is it should have some kind of value object, not a mutable field, and this value object is immutable. Okay, so next is that how all these value objects and the entities. Okay, next concept is that entities, entities, this is described with some kind of describe some identity, right? So how this changes, we are having two agents. One is that semantic understanding, that will be doing semantic understanding agent and semantic validation agent. So now you can understand that semantic understanding agent is related to the ontology. Tomorrow in day 4 we will take this domain model and turn it into an actual schema state architectures. Okay, so what happens now, these frameworks, whether the LangGraph or any other kind of frameworks that we use to build any AI agent system, that introduce a state graph abstractions and how to assign some explicit ownership to each piece of state, and how to maintain the update of this without losing the auditability, that means versioning the proper information. So when we are versioning this one, so any kind down 7 days or the 10 days down of this, if there is some kind of error, then it will be very easy for us to debug the complete system. So state schema definition is very much required and important in while we start the system design of our agentic AI systems. So this session, day 3 session, is very much important so that we can start tomorrow's session. So stay tuned. Thank you.